Hello guys, welcome to learning microcontrollers. In this video I am gonna show you how we can interface two into PIC16F877A microcontrollers with each other using digital input output pins. So let's get started. For this purpose we need two into PIC16F877A microcontrollers, two into LEDs, two into push buttons. So in this example I am gonna show you how we can do this, but later on you can derive applications yourselves. I will take two PICs, one PIC and the second PIC. Then I will connect the B7 pin of the first PIC with the second pin using a wire. Then I will connect the B6 pin to the B6 pin of the first PIC. That is B7 to B7, B6 to B6, pin 40 to 40, 39 to 39. And then I am gonna take two push buttons. I will connect one each at the B0 pin of each PIC. Then I take two LEDs. I connect each at B5 pin of the each PIC. So what's gonna happen is that when I press this push button, that is the push button of the first PIC will be programmed in such a way that once the button is pressed, it will send a signal through the B7 pin, that is 1, and the second pin will receive this signal, and it will be programmed in such a way that it will turn on the LED at B5. And what happens when we press this push button? It will do the right opposite. Now second PIC will be programmed in a way that it will send a signal through B6, and first PIC will be programmed in a way that it will receive this signal and will turn on the LED at B5. So it is a simple communication, two-way. So let me show its Proteus simulation. Okay, here turn on the Proteus, go to ISIS, select PIC16F877A. Here we go, our PIC. Place one here side by side, two PIC here. Then we need two LEDs. We need color LEDs. Okay, blue will do. Okay, take the blue. We will connect them at B5, that is pin number 38. Okay, B5, that is pin number 38. Connect them. Okay, they are connected. Ground them. Go here, select ground. Okay, LED first is grounded. Similarly, ground the second LED. Okay, it's grounded. Now select the push buttons. Go to components, push button. Okay, here we go the push button. We will connect them at B0, that is that here. Okay, B0 here. Now as you know, with the PIC microcontroller you always need a push up or push down resistor. So I'm going to use a push up resistor. So in this case when the button is pressed, a 0 will be sent. So we will program it according to 0 as input. Now we need the power source for the buttons. Click here, select power. Okay, power will go to the one end of the resistor, from other end it goes to the button, and other end of the button is grounded. I had shown how to connect button in my other video, complete guide, that how you can use buttons with a PIC microcontroller. Okay, here we go. Now for output is always taken from the center, from this side. When we are sending 0, when we are sending 1, it will be taken from the other side, and resistor will be on the other side as well. Okay, here we go. This is our output. So when the button is pressed, a 0 will be sent. Now we need to connect B7 to the B7, that is pin 40, with the pin 40 of the other PIC, and pin 39 with the pin 39 of the other PIC. That is pin number 40 goes to 40, and now 39. That is pin number 39. It goes to the pin number 39. Okay, that is 39. Okay, our connections are complete. Now let's get to the programming. Click on new, MicroC for PIC. I'm using MicroC for PIC. Right, give name to the first PIC. First PIC, select PIC16F877A. I'm using a 20 MHz crystal. Okay, here we go. Okay, start programming. First we need to program, you can say, trace declare outputs. P.F7, that is pin 7 is output. Okay, and then trace or give it the initial state, that is B.F7 equal to 0. Initially this pin must be 0. Give it initialization delay, just 100 will be enough. Now do this for the second pin, that is B6. Simply copy paste this, change it to 6. Same, initial state is 0. Now the third one is the LED, that is B5. Same, it is output and initial state is 0. Give them the name O1, you can call it send. For the first PIC, or to receive. For the second PIC it will be opposite, LED. Okay, now the left is the button is at B0, that is B0, and button is an input, so we will use 1, 0 for the output, 1 for the input, and initial state must be 1 because we are using push up resistor. In that case initially it must be 1 because the button will send 0. Okay, now let's this is the one type loop being programmed. Now we go to the infinite loop, while loop. Here now add another resistor for the void here. Now they are complete. Now the first one, we need the transmission programming. For that, if the button is pressed, that is port B dot F0 double equal to 0. If it is pressed, then what happens is that we give it button debounce delay. First delay MS300 will be enough for the debouncing delay. Copy paste the above. Debouncing is needed in case accidentally the button is pressed by some distortion or noise, so nothing should happen to the circuit. Okay, this is a debounce delay. Okay, if B0 is pressed, then port B dot F7 equals to 1, that is a signal is sent to the second PIC. Delay MS300, so it should be enough. Okay, that's correct. At semicolons, close the bracket. Now check the brackets before proceeding further. Okay, it's good. Any additions? Now this is our transmission, that P7 will be a signal will be sent. What happens when it's received? Now we write for the receive wing. Okay, when we are receiving, now continue the above loop, that is else if above that don't happen, this happens, that port B dot F6, that is a receive pin, F6 is the receive, equals to 1. A 1 is received. See, we use double equal to and single equal to, only a bit is needed here. If 1 is received at B6, then what happens is that first complete the loops. Also add a debounce delay over here as well. $300 will be enough. Now copy paste the above here, that's debounce, complete the brackets. Okay, now that's a debounce delay. In case accidentally a signal is sent, it will not alter us. Okay, if B, then LED must turn on, that is port B dot F5 equals to 1, that is LED. MS300, for 300 milliseconds it will remain on. Okay, give it a good shape. Okay, this is our transmission, that is B7 is sent when button is pressed, and when the signal is received from the second PIC, then LEDs turns on. Now what happens if nothing is received? Above conditions are not met, then write else. Then else everything must go to the initial stages, that is port B dot F7 equals to 0, initial state. Give it, copy paste it. Port B dot F6 also goes back to initial state. Port B dot F5 also goes back to initial state 0. Port B dot F0, that is a button, goes to the initial state, that is 1, because we are using 0 logic, that a 0 will be sent. This is a code for the first PIC. Now we do for the second PIC. For the second PIC, just write the name, second PIC, PIC16, 20 MHz crystal. Copy the whole code, paste it. Here it will go opposite. Send will be receive will be send. That, and button is LED is LED, button is button. Here too, sending pin is B6 and receiving pin is B7. Rest is same. So this is a code for our second PIC. Okay, here we go. First PIC, and this is our second PIC. Go to the Proteus. I'm using 20 MHz crystal as mentioned in the programming. Open up. So first PIC. For this one I'm also using 20 MHz crystal. Open up. Okay, here we go. Click on the play simulation button. Okay, I press this button. See, the LED turned on. It turned off. Now I do the opposite. It turns on. When I leave it, turns off. I do it again. I press this. LED turns on of the second PIC. But when I release it, nothing happens. When I press it, LED turns on. When I release it, nothing happens. So this is our basic demonstration of PIC. Now I show you its hardware implementation as well. Let's get to the hardware implementation. Okay guys, here is the hardware implementation. We have our first PIC, we have our second PIC, and this is the yellow wire. Here is our button of the first PIC, and this over here, the orange wire, blue wire, this is the button of the second PIC. So when I press this button, see, now when I press this button here, LED over there turns on. I release the button, it off. Now I press it again, it turned on. And when I press this button over here, LED over here turns on. The connections are as I showed you in the Proteus. Okay, I release it, turns off. See, pressed, it turns on. Okay, when I press it, turns on, and when I release it, turns off. Okay, so guys, it's a basic demonstration. You can derive other applications as well out of this video as you like. So I hope this video helped you up somewhat for better understanding of PIC microcontroller. So see you in other videos. Thank you very much for your time. So have a nice day.